Hey guys, this is a pretty quick video on a problem that is in section 4. And it's actually a problem that we've dealt with in, I don't know, all the way back to algebra, but it has a differential equation feel to it. So I'm just going to do it real quick and remind you how it's done in case we see it again. So it says the amount of A of T of the atmospheric pollutants in a certain mountain valley grows naturally and is tripling, okay, tripling every 7.5 years. If part A, B, and C. So if the initial amount is 10 PUs, or pollutant, that's a good name for it, pollutant units, write a formula A of T giving the amount in PU present after 2 years. So, okay, so the way this goes is when you first encounter differential equations in Calc 2, you go like, the pollutants present, the rate at which it changes with time is directly proportional to the amount of pollutants in the system at any time. We solve this as a separable differential equation, and we get, I'm going to use my own notation, I'll just say pollutants as a function of time is P0, which is the initial amount of pollutants in the valley, times E to some constant K times T. So really the problem is, okay, so this is the formula I have. However, I'll change it one little bit because we do know the amount it started with, which is 10 PUs. So we have 10 e to the kt instead of the initial quantity unknown. We do know it, it's 10. Okay, so really that's part A right there. Part B says, how much pollutant, how many PUs are going to be in the valley after 5 years? Okay, so what we do there in that case is, I remind students that this is really a function, okay, that we've gone to. We did the differential equation to reach it, okay. Time t is equal to 0, you've got 10 PUs. When you want to go to 5, the question is, I don't know. But we do know that it triples every 7.5 years. So when we go to 7.5 years, we know it goes from 10 times 3 is 30. Okay, so we can use that information, as you may recall from previous classes, to figure out stuff, more things about our solution. So that we're working on part B right now. That was part A, we did it. Part B, let's figure out the answer to, how much pollutants in 5 years. So what we do is we take our equation and we simply plug in 30 for P of T and 7.5 for T, and that leaves us just K to figure out. You recall this? So very quickly, you divide by 10, you have 3. So e to the 7.5K. You take the natural log of both sides, which is a nice function to know, 7.5K. And finally divide, and you end up with natural log of 3. Let me write that better. The natural log of 3 divided by 7.5. Now I know you're eager to crunch that number, and I think I did somewhere. And let's see where it was. Let's see if I hit that guy. Yeah, it's about 0.146. 0.146. Nevertheless, what I did is I store it in my computer. And now we're going to go after our question. So really the question is, how much pollutants after 5 years? That's found by plugging in 5 for time, but we didn't know K until just now. So I'm going to write K times 5, okay? When I do this, I just put it in the calculator and I recall my K value because I like to have it as accurate as possible. And when we do that, I think what I got was roughly 20.8. Now that goes right here next to 5 in our table. So after 5 years, we have 20.8 PU. Okay, pollutant units. All right, and that's how that's done. You can pause and stare at it. I'll just jump real quickly to part C. And part C, if we roll back up there, it says, if it will be dangerous to stay in the valley when the amount of pollutants reaches 100 PUs, how long will that take? Okay, so back to our table. This time, I shouldn't say P, well, anyway, this time I'm going to force the pollutants to be 100 PUs. Okay, and then the question is, well, how much time does that take? Well, okay, take our equation down And what we'll do is, we did this before, but we're going to plug in 100 for P. And over on the other side is 10e to the kt. We know what k is. And all we have to do is, now we're solving for t instead of p. So we divide by 10, and you've got 10 is equal to e to the kt. So k times t, because we don't know what it is the natural log of 10. So now we just divide by k, still in my calculator, and what I got was roughly 15.7. So 15.7 would mean in the time column, years. So in about a little over, almost 16 years from now, we can't live in the valley. And that's all she wrote about this one. In case you needed the help, it's fun to see it again. And it's a great problem. I will see you at the next one.